mathematics!
I am the Mathman! I am Supermath! Supermath is a threat to society! I must defeat him!
Aren't you dead?
I've been inexplicably reincarnated.
Come at me, bro. I found the kryptonite that defeats you!
Too late! I am immune!
What about a snake? What about Thor's hammer?
You will never defeat me, Batman.
Crap. What if I find rectangular prisms of kryptonite that have volume equal to the surface area?
No! My only weakness!
Find rectangular prism-shaped kryptonite such that its volume is equal to its surface area.
To the math cave!
Let's name the side lengths A, B, and C. The surface area of this prism would therefore be 2 times the quantity of AB plus BC plus AC. Simplified, this is half equals 1 over A plus 1 over B plus 1 over C. We can establish an upper bound for possible values of A, B, and C without a loss of generality, since our variables are interchangeable. In other words, A is less than or equal to B, which is less than or equal to C. Let's try A equals 7. Oh no, it does not work. If A is 7, then B and C must both be 7 or greater. However, 1 over 7 plus 1 over 7 plus 1 over 7 is 3 over 7. And if B and or C are greater than 7, then 1 over B and 1 over C will have even lower values.
Because 3/7 is less than 1/2, anything lower than 3/7 will also be less than 1/2 and violate our equations.
If A is greater than 7, the same effect occurs since B and C must also be greater than 7. As A increases, the sum 1 over A plus 1 over B plus 1 over C gets lower, and therefore A cannot be greater than 6. Therefore, A must be 1, 2, 3, 4, 5, or 6. If we then plug each of the possible A values into the equation 1 over A plus 1 over B plus 1 over C equals half, we get the following equations. 1 over 6 equals 1 over B plus C, 1 over 4 equals 1 over B plus 1 over C, 1 over 3 equals 1 over B plus 1 over C, 3 over 10 equals 1 over B plus 1 over C, 0 equals 1 over B plus 1 over C, or negative half equals 1 over B plus 1 over C. Because B and C must be positive integers, it is impossible to get the last two equations, and we throw them out. Let's simplify the four equations that do work. 6C over C minus 6 equals B, 4C over C minus 4 equals B, 3C over C minus 3 equals B, 10C over 3C minus 10 equals B. In order for B to be an integer, each one of these equations must simplify to an integer. This means that the denominator of each equation must be a factor of the numerator. Let's take each equation individually at a time.
As Mathman vaguely remembers, we can determine when the denominator is a factor of the numerator by factoring the numerator. In this case, we find that 6C factors into 2 times 3 times W times P. By taking each possible factored value from 6C and setting it equal to C minus 6, we can find all possible values of C. For example, in this case, we know that 6 is a factor of 6C when we take up the W and the P.
So,
6 minus 6, and therefore C equals 12, is a possible solution. This chart shows all the possibilities for C when A is 3. We can disregard any results for C under or equal to 6, since C minus 6 will be negative or 0 if so, neither of which are allowed. So C can be equal to the following: 7, 8, 9, 10, 12, 15, 18, 24, or 42. Some of the equations that we have solved are in the form P equals X plus 6 over W. This is because sometimes the denominator will have a W term in it. We solve for these through the same process. W must be a factor of 6, which means that it must be 1, 2, 3, or 6 itself. We then plug back in to find P, and multiply W by B to find our final solution for C.
Ha ha ha. Keep watching, it only gets better.
We make a similar chart for A equals 4. We can again solve for the values of W, and find that C can be the following: 5, 6, 8, 12, or 20. This one has fewer cases to try since 4C has less factors than 6C. Again, we make a chart for A equals 6. When A is 6, we are actually factoring 3C, which means that there are fewer cases still. Finally, we can make a chart for when A equals 5, and start by factoring 10C. It turns out that this chart only produces two solutions, one of which has already been found. After eliminating the repeat solutions, we find 10 rectangular prisms that fit the conditions. 3, 7, 42. 3, 8, 24, 3, 9, 18, 3, 10, 15, 4, 5, 20, 4, 8, 8, 4, 6, 12, 5, 5, 10, 6, 6, 6, 3, 12, 12.
and just to check, we made a Python program and plugged it in.
This Python program simply tries every combination of A, B, and C in the range 1 to 100. It also removes duplicate answers, such as the difference between 5, 10, 5, and 5, 5, 10. It will return 10 unique dimensions of the rectangular prism.
As you can see, our answer was correct.
Take this, Supermath.
Oh!
Back of undefeated.
Thanks for watching!